Now we'll do practice question 1. Given that y equals to 2x cubed plus 3x squared minus 12x plus 7, find the range of values of x for which y is increasing. Okay, so you're asked to find range of values of x. So again, your answer is an inequality. Inequality in x. Okay, and they're saying for which y is increasing. So the concept here is when y is increasing, it means that the dy dx is greater than 0. Okay, so of course this means that I have to go and find out what's my dy dx. So we'll differentiate our function. Okay, that gives us 6x squared plus 6x minus 12. Right, so after you differentiate your function, because when y is increasing, this function has to be greater than 0. Okay, and then we'll solve this inequality. Notice that all the three terms has a common factor of 6. So I'm going to factorize out that common factor of 6 and then divide that away so that I don't have to deal with that extra factor of 6. Okay, then this is a quadratic inequality again. So we have to factorize, sketch, and solve. Okay, so factorize first. This will be... Okay, this should be the factorization. And then we will sketch. Sketch this. And then we solve it, -2 and 1, because we are looking for the parts that are greater than 0, which is this part of the graph. So the answer will be, therefore, x is lesser than -2 or x is greater than 1. Okay, so this will give us the answer for practice 1. Alright. Okay, and you can also go into decimals.com to sketch out this graph, and then we can see that actually between from these two range of values of x, the gradient, the graph is actually increasing. Okay, so maybe I can show all of you that. Let's go into decimals.com. Graphing. Okay, and you can access this website on your iPads as well. So we have y equals to 2x cubed plus 3x squared, 2x cubed plus 3x squared minus 12x plus 7. Okay, so plus 7. Alright, and you can see that the points, okay, so you can see that the graph is going up before it comes down, and then after it goes up again, right? So here the maximum point is actually at -2, right? X equals to -2. So before x equals to -2, lesser than x equals to -2, you have a graph that is actually increasing from left to right. And then between -2 to the minimum point, which is 1, is actually decreasing. Yeah, and then 1 onwards is increasing again. So that actually ties in with what we found here, right? See, lesser than -2. Okay, it's an increasing function when it's lesser than -2, and it's an increasing function again when it's greater than 1. Okay, but when it's below that, it's all decreasing. Yeah. Okay, so this is the general idea. Your actual graph can actually show you the behavior of the function as well. Okay. Okay, so now we can look at practice 2. Okay, practice 2 is slightly different the way the question is phrased. Asks you to show that the function is increasing in the intervals for x less than 0 and x greater than 0. So you have to show this. Okay, you have to show that when x is lesser than 0 and when x is greater than 0, the dy dx is actually greater than 0. Okay, so show that dy dx is greater than 0 when x is lesser than 0 and x is more than 0. Okay, so we will have to go and differentiate this function first. Okay, we will let function be y. Okay, and how do we find the dy dx? Which formula should we use? Okay, can you see that this is actually a fraction? This is a fraction and there's a function in the numerator and the denominator. We should be using quotient rule, right? So using quotient rule, u is the numerator and v is the denominator. Okay, and then we will differentiate the numerator as well as the denominator. Okay, then recall the quotient rule. Quotient rule is given by d over dx. When you're differentiating u over v, you take v u prime minus u v prime over v squared. Okay, so we're gonna do that. Dy over dx equals to v, which is x, u prime is 2x minus u times v prime. V prime is just 1, so we can just write this as bracket x squared minus 6 divided by v squared, which is x squared. Okay, then you're going to simplify this. Okay, and your answer for the derivative function is this. Okay, so you have to show that the function is increasing in these intervals. Okay, so when, okay, can, okay, so now when x is greater than 0, okay, we will have x squared greater than 0. Okay, so x squared plus 6 is greater than 6. Okay, so since dy over dx is greater than 0, okay, so since x squared plus 6 is greater than 0, dy over dx is actually greater than 0 for x greater than 0. Okay, so similarly, when x is lesser than 0, the x squared is still greater than 0, right? Because when you square a negative number, it becomes positive. Then x squared plus 6 is again greater than 6. So therefore, since x squared plus 6 is greater than 0, dy over dx is greater than 0 for x is lesser than 0. Okay, so we have shown that. Alright. Okay, done. Now you can try the next example.